Hey guys, this is the Unit 4 review packet practice test guide. Starting with the front side, this is the sort of the need to know. Everything you got to know for the test. Need to know means memorized. If that's not clear. Memorize. Like you have to know this cold. So here we have the setups for the different rules. So again, product rule, that is multiplication when you have one function times another function. And you should know the derivative would be f of x times the derivative of g of x plus g of x times the derivative of f of x. And that can be uh, easy to remember through left d right plus right d left. Left times the derivative of the right plus right times the derivative of the left. Next up, chain rule. So remember, this is where you have a function inside another function, composite function. Okay. I'll write that down. This is multiplication. Multiply. This is composite. And here we would have the derivative is the derivative of the outside, keeping the inside the same, times the derivative of the inside. Okay. And then lastly, we have quotient rule. Quotient rule is very similar to product rule. It's g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. Okay. So important here to notice just the order. So start with the g of x. If you remember to start with g of x, and you remember to alternate them, and that each one has to be paired with the derivative of the other, and that you subtract, and it's all over g of x squared. Also remember that f of x is always in the numerator, and g of x is always in the denominator. Okay. Next up is the trig derivatives. So starting on the left here is sine, tan, tangent, and secant. Derivative of sine is cosine of x. Derivative of tan is secant squared x, and secant x is secant x tan x, or tan x secant x. Doesn't matter. Order does not matter there. And these are all positive. Okay. On the other side, the trig functions all have negative derivatives. So cosine is negative sine, cotangent is negative cosecant squared x, and cosecant is cosecant x, negative cosecant x, cotangent x. Okay, so you need to know these six. Cosine, sine are review, but the new ones, these four, you want to memorize. And there is a pattern there. You can see these three and these three are kind of matching. They're kind of opposites of each other. And then lastly, we have the fundamental theorem of calculus with chain rule. So this is where you're taking the derivative of an integral, but it's two functions. And I'll go ahead and just give you the simple formula. It's going to be f of g of x times the derivative of g of x minus f of h of x times the derivative of h of x. And if you know that, that's enough. Okay, if you know that, that's enough. I won't go into detail about the why behind that. But this comes from the fundamental theorem of calculus, where we're doing, you can imagine, f of x from h of x to g of x. Then that becomes f of g of x minus f of h of x. And then you take the derivative of that, and that's how you get there. Derivative, and then that's how it gets there. So again, just to remember that. But this is what you need to know up here, and that's it. I mean, it's not that much to memorize. So you have the rules, the trig derivatives, and then the fundamental theorem of calculus, which is just adding that chain rule part. Okay, we're going to start with some problems. I'm going to do these on a separate sheet. So these first three are all product rule. All product rules. So we have 1, A, 7x plus 10, 2x plus 3. So actually, this one would be very easy to solve by distributing. But I'm going to go ahead and solve it product rule as we have been doing in class, just for consistency. So we have f of x equals 7x plus 10, g of x equals 2x plus 3. Derivatives are 7 and 2 respectively. And so I'm going to do left d right plus right d left. So it's going to be 7x plus 10 times 2 plus 2x plus 3 times 7. That's 14x plus 20 plus 14x plus 21, which gives me 28x plus 41. Right there. Okay. That is 1A. B. This is 1B. We have 3x minus 2 times the square root of x plus 5. So again, I've kept repeating this. I'll continue to repeat this. When you see radicals, this is called a radical. Reminder, radical. To take the derivative of the radical, you first need to convert it to an exponent. So this drops down as normal. 3x minus 2, we are not going to change that, but we're going to rewrite that square root as x plus 5 to the power of 1/2. Now I can do power rule to solve this. Okay, so same thing. F of x equals 3x minus 2. Derivative equals 3. G of x equals x plus 5 power of 1/2. Derivative equals 1/2 x plus 5 to the negative 1/2. And you might think, oh, this is chain rule because we have a function inside another function. But notice that the derivative of the inside of this is 1, so it's not going to change anything here. Okay, and then we put it all together. Left d right plus right d left, so it's going to be 3x minus 2 1/2 x plus 5 to the power of negative 1/2 plus x plus 5 to the 1/2 3. And this is fine. Again, I've said this before, that on the AP test or on a content, usually the multiple choice is in the simplified version, so it's helpful to understand what that looks like. And just for the sake of it, I'll show you. So this one would turn into 1/2 root x plus 5, and then that 3x minus 2 would multiply by it. So this on top would become 3x minus 2 over that. Then it would be plus square root of x plus 5 with a 3 in front. Because that 3 would come out front. So like this is fine. I'm just going to square this one up. But this, in case you were curious, that's how it would simplify. Moving on. 1c, we have 5x plus 1, 4x squared plus 3x minus 9, f of x equals 5x plus 1, derivative equals 5, g of x is 4x squared plus 3x minus 9, derivative is 8x plus 3, plug it in, we're going to get 5x plus 1, 8x plus 3 plus 4x squared plus 3x minus 9 times 5. Okay, so that's lefty right, righty left. And then that's fine. Okay, and you know how this one is easier to simplify, so I'm not going to go into that. Okay. 2, we are into chain rule. First one, f of x equals x to the 5th plus 1 squared. So we have this out. I know this is chain rule because I have an outside. You could also turn this into a product rule by rewriting it as x to the 5th plus 1 times x to the 5th plus 1. You could do that. But because I know, because it's easily identifiable as chain rule, I'm going to do chain rule. So derivative of the outside first. Outside is to the power of 2, so I'm going to do 2x to the 5th plus 1, just the power of 1. And then the derivative of the inside, which is 5x to the 4th. And that's it. Okay. Yeah, again, I could simplify that more. I'm not going to. Okay. That's A. Then B. We have f of x equals cube root x squared minus 2x plus 1. Okay, if you're following along, what is this called? And what did I just say you have to do when you see this? This big check mark symbol is, we usually call that square root, but it again is called a radical. And when you see that, you should be thinking in your head, I need to convert that. That needs to be converted into an exponent. So that's what I'm going to do immediately. X squared minus 2x plus 1 to the power of 1/3. So remember that the root is the denominator here. And all of this, right, is to the power of 1. So that's where that 1 comes from. If all of this was squared on the inside, then it would be 2/3. But it's 1/3. Now, okay, chain rule. It's just like above, power on the outside, function on the inside. First, the outside. We have 1/3 x squared minus 2. Inside stays exactly the same. And then what's a third minus 1? A third minus 1 is negative 2/3. And then the derivative of the inside will be 2x minus 2. That's it. Okay, that's all I expect on the test. Okay, again, this one would be this. Okay, all right, we're continuing. This is 2c. F of x equals sine squared 5x minus root x. Okay, so this one's a tiny bit trickier. So what you need to notice, well, this is a chain rule problem, and that's clear by the function inside a function. You can see, oh, this is parentheses, and this we're taking sine of something. But also notice this square on the outside means that we're squaring the entire the entire function. So we're squaring sine of 5x minus root x. The notation, really, this kind of belongs out here. You can picture, but we don't write it there. We always put it here just to make it really clear that we're squaring the function, not this value. Like we're squaring it after we take sine, if that makes sense. So this is our first step, is to deal with that too. So this is power rule. We're going to 2 out front. We have 2 sine 5x minus root x. Next step, we're going to take so that's done. We're done with number 1. Checked off. That 2 is no longer part of it. We've peeled that layer off, if that makes sense. Then we're on sine. What's the derivative of sine? Should know that. Cosine. So then we have cosine 5x minus root x. And then we're going to take the derivative of the inside of this, 5x minus root x. Derivative of 5x minus root x is going to be 5. And then, remember, I keep on saying this over and over again. If you think about root x, that is x to the power of 1/2. So really, this is minus 1/2 x to the power of negative 1/2. And that's it. That's a kind of a double chain rule because you have 2 outside functions. You have that square, and then you have step 2, which is the sine, and then you have step 3, which is the inside here. Okay. All right, we're on 3. These are quotients. First one is f of x equals 3x squared minus x squared all over 1/4 cosine x. So again, for a lot of these, you can do them as product rules by bringing this denominator up to the top and then doing product rule. That's totally fine. I am going to do these quotient rule style though. So again, numerator is always f of x. So f of x is going to be parentheses 3x squared minus x, all that squared. And then my derivative of that is it's a chain rule. So you have to do a chain rule in this. 2 is going to come out to the front. 3x squared minus x is the outside, times the derivative of the inside is that's 6x minus 1. Okay, so that's the numerator. I got it from here. That's the derivative of that using chain rule. That's the outside, that's the inside. G of x is the denominator. And then the derivative of the denominator is negative 1/4 sine x. And we're good to go. Once you have your values here, you are good to substitute in. So I'm going to do that over here on the left. So it's, again, I know to start with g of x, 1/4 cosine x. I hope I left myself enough room. I don't think I did. Okay, I'm going to do it down below because I'm going to run out of space. Okay, 1/4 cosine x, derivative of f of x is this whole 3x squared minus x, 6x minus 1. Then minus f of x is 3x squared minus x squared times the derivative of g of x, that's negative 1/4 sine x all over 1/4 cosine squared x. So just to kind of, I'm going to help label this. I know this seems complicated, but I'm just substituting. That's the g of x right there. This right here is the derivative of f of x. This right here is f of x. This right here is the derivative of g of x. And then this right here is g of x squared. So it's about identifying f of x, g of x, and the derivatives, and then plugging it in. If you can do those 2 things, you're going to be just fine. 3b. Yeah, 3b is similar. It's a mixed. It's got some chain rule in there. So we have f of x equals sine x over 3 2x minus 1 squared. So same steps. Like, guys, if you are following along with this at this point, you should just do this, because this is just like the previous problem. Like, there's no reason that you need to watch me do it. At least attempt it. Fx is sine x. Derivative of sine x is cosine x. G of x, the denominator, is 3 2x minus 1 squared. The derivative of that is 2 times, this is a chain rule. 2 times 3 is 6. That's 6. 2x minus 1 times the derivative of the inside. That's a 2. So it's going to be, I'm just going to simplify this to make it easier because it's really easy. 12. So that's 24x minus 12, because 2 times 6 is 12. 12 times 2 is 24. 12 times negative 1 is negative 12. So that's g of x right here. Derivative of g of x. And then plug in. So 3 2x minus 1 squared cosine x minus sine x 24x minus 12 all over 3 2x minus 1 squared, all of that squared. And that's it. Okay. All right, we got some trig derivatives for number 4. For a negative 7 secant x minus 1. Okay. That parentheses does not need to be there. I'm going to rewrite it. F of x equals negative 7 secant x minus 1. Okay. So we should know derivative of secant is secant x tan x, right? So the way that we're going to do this is that negative 7 is going to stay out front. We're not going to do anything with that negative 7. I know this is secant x tan x. So this is going to become secant x minus 1. That just comes down. Tan x minus 1. So when we say secant x tan x, you got to keep that x minus 1 in both of those slots. Okay, and then this is a bit of a chain rule, because then we would multiply by the derivative of the inside, but the derivative of the inside is just 1. So I'm done. That's it. B. 6 tan x minus root x plus 1. Okay, again, derivative of tan, you just got to know it. That's, again, 6, the constants stay. It's 6 secant squared x minus, this is, so with addition and subtraction, there's no special rules. You just do them one at a time. So again, I'm going to rewrite this here. What is this called? This is a radical. This is a radical. One more time, I'm going to label it radical. Convert. That's the 1/2 power. Okay, so that becomes 1/2 x plus 1 to the negative 1/2, and that's a little bit awkward, but that is the final answer. 1/2 comes out front, minus 1 from the 1/2. The derivative of the inside is just 1, so it's just easy. All right, we're moving on. Okay, this is for C. F of x equals 2x cosecant 3x. Okay, so this one's a little bit different. This is going to be a product rule. Notice that we have 2 different functions. Product rule. So let's go ahead and say f of x equals 2x. Let's say derivative f of x equals 2. G of x equals cosecant 3x. And derivative of g of x equals negative cosecant 3x cotangent 3x. So this is a chain rule, and I just want to pause for a second and explain to you what's happening, because I do remember this when I took AP Calculus 10 years ago. This confused me. What's weird about the derivative of cosecant and secant as well is that two functions pop out of it. Like one function goes in and two functions pop out, and I always found that difficult because I didn't understand. I think I didn't understand like what happened inside. But what I want to make clear to you is that whatever's inside of the original cosecant is what goes inside of the new cosecant and the new cotangent. Like this remains. And that always confused me. So I just want to make that super clear. This is also a chain rule. We did the derivative of the outside, which is negative cosecant cotangent, but then we have to do the derivative of the inside, and that's 3. So derivative of 3x is 3. Does that make sense? So negative cosecant cotan, 3x is 3. Okay? And then we plug it in. So it's going to be 2x times this whole thing here. I'm going to go, just so you see what I'm doing, I'm moving this 3 out front. This 3 does not combine with these functions, like the cotangent 3x, cosecant 3x, like this 3 cannot mess with those. I just want to make that clear. So I'm going to move it out front. So it's going to be negative 3 cosecant 3x cotangent 3x. Plus cosecant 3x times 2. That's it. Okay. For D, we got f of x equals 5, x minus 1 cotangent negative third power x. So again, another product rule. Notice that this is a function right here. This is a function right here. Same thing. F of x equals 5x minus 1 derivative equals, this is just 5. I mean, you can get that multiple ways. You can just say derivative of x is 1 plus the, and then you multiply with a constant out front, or you could do 5 times x. This is 5x minus 5. The derivative of that is 5. Either way, it's fine. G of x is cotangent to negative third x. The derivative, this is going to be a chain rule. So again, that outside, this is the first negative. That power really is is the power of the whole thing. So that comes out front. This is going to be negative 3 cotangent to the negative fourth power x, and times the derivative of what's inside, which is negative cosecant squared x. Now I got it all together. I just have to substitute. So it's going to be 5x minus 1, this whole thing. So I'm just going to put big brackets in front of negative 3 cotangent to the negative fourth x, negative cosecant squared x, close brackets, plus cotangent negative third x times 5. So again, I mean, I'll label this one because it's a bit complicated. This is f of x. This is the derivative of g of x. This is g of x. And this is the derivative of f of x. Okay, moving on. Okay, we have some fundamental theorem of calculus chain rule problems. Okay, so first one, these are all kind of run together. Okay, this is 8a, but they're 8 and 9 are all really similar. 8a says the derivative of from 5 to x squared of 3x plus 1 to the third dx. And again, this is the formula you got to know. So it's plug in, this is like your g of x, that's your h of x, and or wrong way around, that's h of x, that's g of x. It doesn't really matter. All you need to know is that you plug in that x squared in here, and then you multiply by the derivative of that, and then you minus this number put in here times the derivative of that. So I'll explain as I write it out. So it's going to be, again, the formula is in your notes, but it's f of g of x times the derivative of g of x minus f of h of x times the derivative of h of x, where this is h of x, this is g of x, and essentially this is f of x, or this is f of t. So once you understand the formula and you know how to identify it, you're plugging it in. So it's going to be 3, and then it said the x is going to be x squared. So put an x squared in there. 3x squared plus 1 to the third times the derivative of x squared is 2x. And I'll write this out, but I don't need to, and I'll show you why. Minus, it would be 15 plus 1 to the third times the derivative of 5, which would be 0. So this cancels out because the derivative of 5 is 0. This is my answer here, okay? B. We have derivative from 3 sine x to 4 of root x squared minus 2 dx. So it doesn't matter how scary this looks like in here. Like, it can be as terrifying, doesn't matter, because you're not doing anything to it apart from substituting these values in for x. So for this one, it's good. It would be, so again, try it. It would be 4 squared minus 2 times 0. So put the 4 in for x. Then I took the derivative of 4, that's 0, minus square root of 3 sine x, all of that squared, minus 2, times the derivative of that would be 3 cosine x. So that would be the answer right here, because this will cancel because of that 0. So again, constant terms in here get canceled out. Constant terms in here will get canceled out, okay? Because the derivative of a constant is 0. But again, this is negative. Oh, this is important before I finish. It's negative all of this. Okay, let's make that clear. It's negative all of that. Okay. C. Oh, this is 9a now. 9a, derivative from negative 3 to 4x squared, secant root t plus 5 dt. Okay, the t it doesn't change anything, doesn't change the process at all. It's the same thing. So we're going to plug the 4x squared in. Secant square root 4x squared plus 5 times that derivative, that's 8x. And then because that's a constant, I'm now at this point I'm not going to bother. That is the answer. This would basically be minus 0 because that's a constant there. So when I plug that in and then take the derivative of that, you get 0. Okay, same. That's why these are canceled here. Okay, 9b. We have derivative from sine x root x t squared minus 5t plus 2 dt. So this one, notice we've got two functions. We're going to be keeping both functions. Both functions are going to be we're going to have a longer expression here. So we start with the top one. It's going to be root x squared minus 5 root x. Everywhere there's a variable, you're plugging in that root x plus 2 times the derivative of root x. Now this should be getting familiar with the derivative of root x. Again, one more time, it's x to 1/2. So that's 1/2 x to negative 1/2. Which I didn't mean to put right next to it. I'm just going to scribble that out. I'm putting it here just for consistency. 1/2 x to the negative 1/2. That's the derivative of root x minus, plug in sine. We're going to get sine squared x minus 5 sine x plus 2 times the derivative of sine is cosine x. Okay, that's 9b. Okay, moving on to some table and graph problems. So here we are. Using the table, find the derivatives of the following functions. So first one, k of x equals f of x over g of x. Find the derivative of k of 0. So you notice, guys, f of x over g of x, what's that? That's a quotient. So we want to use quotient rule. But we're finding it specifically at 0. So we are going to substitute 0 into the quotient rule. So again, you got another quotient rule to engage with this. But it's going to be g of 0, derivative of f of 0 minus f of 0 times the derivative of g at 0 all over g of 0 squared. And I have all those values here, so I'm just going to plug them in. G of 0 is 3. Derivative of f at 0 is negative 5. Minus f of 0 is 1. Derivative at 0 is 2. All over g of 0 is 3 squared. What does this simplify to? That's negative 15 minus 3 is negative 18. Negative 18 divided by 9, this is negative 2. Okay, so you notice, okay, the function is a quotient. I'm going to use quotient rule. I'm finding at this specific value. So I'm going to just plug in that value and then substitute from the table, and that gets me it. Okay. Similar for h of x, you notice that this is a product, so it's going to be product rule. Lefty right, righty left, f of x, g prime of x plus g of x, f prime of x, but it's specifically at 3. F of 3, g prime of 3 plus g of 3, f prime of 3. And we're just going to plug them in. So So f of 3 is 8. The derivative of g at 3 is 4. Plus g of 3 is negative 5. And then derivative is that's 3. Derivative of f at 3 is 3. So that's 32 minus 32 minus 15 is 17. And we're good. Okay. Same process. Okay, this is the same thing, just chain rule. So I know that this is at 0, so it's going to be the derivative of f at g of 0 times the derivative of g at 0. So this one on the right is easy, because I'm just going to grab that from here. The derivative of g at 0 is 2. So this is just 2. Now, what's difficult a bit about this one on the left is this, it's a composite function. So what's g of 0? Well, g of 0 is 3. So really, this is saying the derivative of f at 3, because g of 0 is 3. You understand what I'm saying? So g of 0 is 3. So really, this is f, the derivative of f at 3. Well, what's the derivative at 3? That's here above. The derivative at 3 is 3. So this is 3 times 2 is 6. That is 6. We're going to get a little bit more practice of this on the back. So this is essentially the same thing, but you have to do a little bit more of the heavy lifting, and you actually have to find those values via graphs. So the first one here, it's chain rule. You notice that because it's a function inside a function. So we want the derivative of f at g of negative 7, and then times the derivative of g at negative 7. Right, that's chain rule. Derivative of the outside, inside the same, times the derivative of the inside. So again, just like the other one, the derivative of g at negative 7 is actually really easy to find. So we're going to go to g, the graph on the right. We go to negative 7. Negative 7 is right here. When we look at that rise over run, you see the rise over run of this. It's negative 2 down and 1 over. So therefore, g of negative 7 must be negative 2 because the slope is negative 2. So that means that this is negative 2 because the slope of g at negative 7 is negative 2. And then we're going to do the derivative of f at g of negative 7. Well, like the other one, we have to know what that g, we have to find what g of 0 is 3 and then book 3 into that. It's the same thing. So what's g of negative 7? So g of negative 7 means the output of g at negative 7. You see here, g of negative 7 is negative 1. When I plug in negative 7, see here I'm at negative 1. So this is the derivative of f at negative 1. Okay, so now I go to f, negative 1, go down. The slope here is 1. I can see that because it's going over 1, up 1, like that. So this is just 1 times negative 2. So this equals negative 2. So you might want to pause and slow that down in case that was kind of confusing. This is the most challenging one of the graph problems because of that weird, you have to go find that value and then plug it into the derivative of another one. That's the only reason that's difficult. Okay, I've had to make a little cut because these values don't work. I've solved them with these values and it doesn't come out very well. So we're going to have to use negative 9 instead, and we're going to kind of ignore the derivative rules for the endpoints for this example. For the sake of the example, the process is the same. It just doesn't work well for these outputs. Like it came out as decimals or it came out as undefined. It didn't work well. So I'll teach you how to do it. So this is product rule. So what you're looking for is the product rule to find the derivative of h of x at 3. We want f of negative 9 times the derivative of g at negative 9 plus g of negative 9 plus the derivative of f at negative 9. And we're going to go find those values. So f of negative 9, we go to f, we go to negative 9, it's negative 1. You see that when you go to negative 9, the y value is negative 1. While we're there, let's go ahead and find the derivative here. So the derivative is a slope. And you can see, what is it? It's actually not negative 1. It is this whole triangle here. It's 1, 2, 3, 4, 5. It's negative 6 and 1, 2, 3, 4. Negative 6 over 5 is the slope. It's not negative 1. So over here, where we have the derivative of f at negative 9, that will be negative 6 over 5. Then we're going to find g. So g of negative 9 is 3. So this would be a 3 here. And then the derivative of g at negative 9 is negative 2. So it's negative 2 and over 1. So that's negative 2 here. So now we multiply. That's 2 plus 3 times negative 6 over 5. Well, 3 times negative 6, that's negative 18 over 5. So not the most clean of not the most clean of answers, but you get the idea. You go find f of negative 9. You go find them from the graphs, and then you plug them into the product rule. And I'm using product rule because this is a product. And then you combine the terms, and that's what we get. Okay, and this is the same thing really, except instead of product rule, it's quotient rule. So it's going to be g of negative 9 times the derivative of f at negative 9 minus f at negative 9 times the derivative of g at negative 9 all over g of negative 9 squared. And because we just found these values over to the left, we can just substitute them again. G of negative 9 was 3. The derivative was negative 6 over 5 minus, it's going to be the same as that over there, negative 1 times negative 2 all over 3 squared. So this is going to come out not super clean. And so it's going to be negative 18 over 5 plus, minus 2 over 9. So again, not the cleanest of answers, but you get the idea. You go find these values at negative 9. So g of negative 9, f of negative 9, the derivatives of these points from here. And then you plug them in. And there's practice for delta on this one too, if you need it. And that is the practice test.